Let us discuss this problem from the chapter of polynomial, which says if alpha and beta are zeros of the polynomial p of x 3x squared minus 2x minus 6, then find 1 by alpha plus 1 by beta. Alpha square minus beta square and alpha cube plus beta cube. We will solve this problem by making use of the relationship between the zeros and coefficients of a quadratic polynomial. Since the given polynomial is a quadratic polynomial, then what we have, if the given polynomial is p of x equal to ax squared plus bx plus c, and if we have alpha and beta to be the zeros of this polynomial, then what we have, alpha plus beta, which is the sum of the zeros, is equal to minus b by a. B is the coefficient of x and a is the coefficient of x squared. And alpha into beta, which is the product of the zeros, is equal to c by a. C is the constant term and a is the coefficient of x squared. Now let us solve this problem. The given polynomial is p of x 3x squared minus 2x minus 6. Now what we know is alpha plus beta is equal to minus b by a. Let me write on the side. What we have, a is equal to 3, b is equal to minus 2, and a constant term c is equal to minus 6. So minus b minus, what is b? Minus 2 by a, which is 3, is equal to 2 by 3. Alpha into beta is equal to c by a, or c is minus 6 and our a is 3. So when we divide, we will get minus 2. Now let us solve this question number 1. 1 by alpha plus 1 by beta. Okay, let us multiply and divide by beta. Same thing here, we multiply and divide by alpha. So we'll get alpha into beta, which is LCM, beta plus alpha. Now we'll make use of these two equations. Let me name this equation as number 1 and this as number 2. Now we'll make use of this equation number 1 and number 2. Let's substitute for beta plus alpha, which is the same thing as alpha plus beta. This will be 2 by 3. 2 by 3. And the product alpha into beta, which is minus of 2. Here we will get minus 1 by 3. So what is 1 by alpha plus 1 by beta? it is minus 1 by 3. Now let us solve the second one, which is alpha square plus beta square. Let's solve alpha square plus beta square. Now what we know is alpha plus beta whole thing square is equal to alpha square plus beta square plus 2 alpha into beta. But what we need is these terms here. So let's keep them in one side. Then it will be equal to alpha plus beta square whole thing square, then minus of 2 alpha into beta. Now substitute the value of alpha plus beta. Two by 3 whole thing square minus 2 and alpha into beta is minus 2. Then it will be 2 square, which is 4, 3 square, which is 9, minus into minus will be plus, and 4. Now if we take the LCM, it will be 9, 4 plus 36. Then this will give us 40 plus 40 by 9. Then alpha square plus beta square is 40 by 9. Now let us solve the third one, which is alpha cube plus beta cube. But what we know is alpha plus beta whole thing cube is equal to alpha cube plus beta cube plus 3 alpha into beta alpha plus beta. We need these terms, implies alpha cube plus beta cube. We'll take this to the same side with this term. It will be alpha plus beta whole thing cube. Then this, if we take to the same side with this term, it will be minus 3 alpha into beta by alpha plus beta. We'll substitute alpha plus beta is 2 by 3. Then whole thing cube minus 3 into alpha into beta is minus 2. Minus 2. Then again, this alpha plus beta is 2 by 3. 2 to the power 3 is 8. 2 to the power 3 is 8. 3 to the power 3, 27. Then let's cancel this 3 and this 3. Then what we have is minus into minus. It becomes plus. 2 into 2, 4. And if we take the LCM, it will be 27, 8 plus.
Why don't you on?
108 is equal to 116 by 27. So what we get is alpha cube plus beta cube is equal to 116 by 27.